Hi everyone, I'm Phil from My Math Teacher is Terrible. Thanks for joining today. We're going to talk about a topic that's sort of interesting. We're going to talk about how we can best solve absolute value equations and how we can better solve absolute value equations. There are a lot of terrible math teachers out there, but I can help. And we can talk about one change that you can make to the way you solve absolute value problems that will actually lead to success in kind of multiple cases. We'll see what we're talking about as we go on. Okay, so let's start by just reminding ourselves like what the absolute value function is just by taking a few examples, right? If I ask you what the absolute value of 5 is, certainly you're going to tell me it's 5. If I ask you what the absolute value of -5 is, it is also 5. And really, let's talk about what we do two ways. First, in English, just like normal people do, you and me, you and your friend, and you and maybe your terrible math teacher, talking about how we take absolute value. And then we'll also talk about the mathematical or sort of algebraic way to do it, which is really the key to this video. Okay, so the first thing we're going to do is talk about it just like normal human beings, not with any sort of mathy language. We say that we take the value that's in between the bars and we drop the sign. You may recall from your basic algebra that if there's no sign, there usually is an invisible plus sign. So this is the same as this. These two things are the same. Perhaps I can do something fancy with another color and say that these two things are the same. So if we consider now these two things here, we could see that what we actually do is drop the sign. Well, actually, that's dropping the sign, right? So that's what I do. I drop the sign and then I remove the absolute value bars. And that's fine, but when dealing with values in the absolute value bars, when dealing with numbers, that is, not variables, not expressions, not anything more complicated than that, this usually is sufficient. When you have some of those like basic questions on a quiz or an exam or a homework that sort of test one skill, can you take the absolute value of a number successfully? Notice the answer is the same. Well, these are both the same. The answers are the same in both cases where you drop the sign and then drop the absolute value bars. That's sort of one question, one skill. Do you get it right or wrong? But as we get into more complicated situations, as we'll see, things can get a little weird, but not too bad. But we really need to kind of revisit some of the first principles of like what this actually means. Let's talk about the absolute value of 5 and -5 for a little bit more. When we deal with absolute value equations or solution sets or things like that, we also want to talk about what absolute value actually means, maybe in a geometric sense. So if I have 5 and -5 on a number line, let's say, I want to talk about why the absolute value of 5 and -5 is the same, namely 5. We're talking about the distance from 0. And we remember from geometry how we mark two lines as congruent. We can do something like this, right? From geometry, we remember that this means that this line and this line have the same length. And from geometry, we also remember that actually any line that has the same length and goes between 2 points is actually the same line segment, right? We talk about that that way in geometry. We don't have to do that here. Really, the point is that I'm going from 0, and there's two directions on this line. To the right is +5, and to the left is -5. And the sign, although there's an invisible plus sign over here, right? The sign tells us the direction from 0 that we go. But at the end of the day, when we take the absolute value, how far did I go from 0? I went 5 along this line. I also went 5 along this line, but just in a different direction. That's kind of the essence of absolute value in this case and in some like simple cases. So that's just a little review of like what's happening geometrically and sort of conceptually. Okay, so let's talk about absolute value equations. Let's talk about the simplest one that we've got. Well, there's two simple ones. One of them is a little tricky, but let's talk about it. Okay, so if I give you an absolute value equation, what would I do here? Well, I know by looking at this, again, just speaking in non-mathematical terms, that this is going to have two answers, right? I know that x can equal 74. I also know that x can equal minus 74, right? Because if I think backwards, which is usually what most algebra is about, if I think backwards, I can check my answers by putting positive 74 in here, and certainly I'm going to get 74. Then I can also put negative 74 in here, and what do? I drop the sign, and I get 74. That's totally fine, pretty easy. But let's alter this equation a little bit. This is maybe where a little bit of the trick comes in, but let's see if you get it. So now I'm going to ask with the absolute value, what number gives me an absolute value of negative 74? And if you think about it for a second, there actually is no such number, because another key detail about absolute value is that it only yields positive answers. So there's nothing I can do here to give me a value of x when I take its absolute value that gives me a negative number. It's a bit of a trick question, but it also speaks to the definition of what the absolute value function is. And for that, let's go to function notation for a moment. Let's get rid of this, and we'll talk about how the absolute value function is defined. So let's say I have a function f, and it is the absolute value of x. What does this mean? It means that when I put in a value of x into this function, it goes here, and then I drop the sign, right? We talked about that. But now we actually have to talk about what we do algebraically, and here's the reason why. If I ask something like x minus 3, absolute value is 4, what happens? Well, we have to sort of figure out what number goes in here for x, and right, if I had no absolute value bars, I would add 3 to both sides and I'd have my answer. Now, I can actually drop the absolute values bars here and do x minus 3 equals 4, add 3 to both sides, and then I would get x equals 7. And I see that 7 minus 3 produces positive 4, and that gives me the absolute value of 4. That's right. But that's only half the answer, right? It's only half the answers, because we saw in the case of 5 and negative 5 what happens. They give me the same absolute value. So what I really have to think about, and this is what most math teachers teach. They teach this. Right? Because I really want minus 4 to be the result in here, that when I take the absolute value, I drop the sign. And that's all well and good. I can add 3 to both sides again. And these will cancel, and I get x equals minus 4 plus 3 is minus 1. Seems good. Let's check our answer. If I put minus 1 in here, I get minus 1 minus 3 is minus 4. And then I take the absolute value and I drop the minus sign and I get 4. Fantastic. That's really how to solve an absolute value equation. And remember, the definition of equation, or how we can tell we have an equation, is because we have an equal sign, right? The word equation has the word equals in it, right? In my terrible handwriting. But that's true. It has an equal sign. Fine. So this will work for any crazy looking thing. I could put a quadratic in there. I could put sine, cosine, tangent. I could put any function I like in here. And this will work for absolute value equations. And so far, your math teacher is awesome. So far, your math teacher is not terrible. Until we get to dealing with something other than equations. And specifically, when we begin to deal with inequalities, we'll see that this approach is actually not so good. Let's do an example. So really, the approach is to break the absolute value expression into two things and then try to deal with it that way. One for the positive case, one for the negative case in the equation sense. But let's do another one. Let's take the absolute value of x plus 6. Oops, absolute value is a straight line. is a 12. And actually, we're talking about inequality, so it's not an equation. I'm going to do this. My memory is also terrible. All right, so it is greater than 12, right? An inequality is greater than, less than, greater than or equal to, less than or equal to, right? We have 4 choices here. So this is an inequality. Okay, so let's think about it. Let's do the approach that our math teacher taught us. And say x plus 6 is greater than 12, and then x plus 6 is greater than minus 12. Let's see what happens. Now this, all we have to do is solve this inequality by pretending there's an equal sign here. Nothing crazy, minus 6 on both sides, right? X is greater than 6. And let's check this answer while we're here. X is greater than 6. Let's choose a convenient value greater than 6. 100. If I put 100 in here, I get 100 plus 6 is 106. And what's the absolute value of 106? It's 106, right? I just drop the sign and drop the bars. And is 106 greater than 12? Absolutely. So this works just fine. Awesome. This one is where you need to pay attention. Here's what happens. I do the same exact thing. I subtract 6 from both sides. This cancels and I get x is greater than minus 18. Fine. X is greater than minus 18. So let's choose a convenient value that's greater than minus 18 to check my answer. The best value to choose is 0. Believe it or not, nothing is greater than a negative number, right? If I go negative 18, 17, 16, blah, 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 I'll eventually get to 0. 0 is greater than minus 18. Let's put it in there. 0 for x. 0 plus 6 is 6. And the absolute value of 6 is also 6. And is 6 greater than 12? No, it's not. And this is where the approach of setting the thing on the other side of the operator, which here is an inequality. Sometimes it's an equal sign. This is where setting this positive and negative fails us. Absolutely. This is not true. This is not true. And this is where the issue is. But fortunately, there's a simple fix for your math teacher being so terrible. Let's have a look. So we're going to go back to first principles and talk about the definition of the absolute value function. So let's see. I'll try to remember this and write it again after we talk about this. So let's talk about the absolute value function. So far, I've not written down any algebra about what it means to take the absolute value of a number. And it turns out for this to have any meaning and for us to do effective calculations on it, we should come up with something like that. And fortunately, it exists. This is well known. And here's what it is. The absolute value function is a piecewise function. That is, there are different rules for this function, this parameter, or for the result based on the type of number I put in here. Right? And I think we all know it. And now we have to translate it into sort of mathy language. Okay? So let's talk about when x is greater than or equal to 0. What is the absolute value equal to? Absolute value of 6 is 6. Absolute value of 5,000 is 5,000. Absolute value of 4 is 4, right? So the absolute value of x when x is positive is x. Right? And now the only other case to cover all numbers is for x less than 0. Excuse me. When x is less than 0 is where we actually have to come up with some sort of thing to actually make a negative number, which is what x less than 0 is telling us, to make a negative number into a positive number. There's several ways to do it, but the easiest way to do it is to multiply this by minus 1. Or to simply say minus x. And let's see if that's the case. So if x is less than 0, minus 5. I put it in here. Minus 5 says I choose this branch because x is less than 0. Minus 5 is plus 5. This is algebra. Dropping the sign and dropping the absolute value bars is like normal English. But math is not normal English, you might have noticed. This is what we have to say. And this is the part that's going to help us out when we need to solve more complicated inequalities. All right, so let's take a second. I'm going to rewrite a bunch of this stuff, and we'll see how that goes. Okay, so I just rewrote the part that we just talked about, which is the actual definition of the function absolute value. Now let's look at our problem from earlier. And of course, I don't remember it, so I'm going to come up with another one. Let's do the absolute value of x minus 5 is greater than 12. Okay, so in light of this information, the approach where I did something like this, which is wrong, which gave us the wrong answer, actually doesn't jive with this at all. It actually doesn't make use of this at all. We think it does, but there's a fatal flaw there. And you'll see when we get the right answer, like what happens and why. But here, this is telling me to do some sort of operation on the thing that I'm given in the absolute value bars. I didn't do that here. I did some sort of operation on the thing that's not in the absolute value bars. So I'm actually not taking advantage of the definition of absolute value of x. And this is where the problem is. Right, we decided that if I add 5 to both sides, this is going to be x is greater than minus 7. If x is greater than minus 7, I can put 0 in here again, right? 0 minus 5, absolute value is 5, which is not greater than 12. This is a problem. So what can we do? Excuse me. We can actually make one change to our approach here that actually will give us the correct result. We're going to use this, which says do an operation on the argument to give us the correct value. Fine. So I'm going to do an operation on the argument. The argument, it says to take the argument, and in the case where I want the argument to be less than 0, put a minus sign in front of it, right? Because I still can have x minus 5 is greater than 12. That part gave me the right answer. Right? Just dropping the bars gave me the right answer. That's this branch. Because whatever is in here is greater than 0, so I just drop the bars. But for this one, I also need to come up with the negative of this. And how do I do that? I'm going to introduce my friends, the parentheses, for this, greater than 12. Okay? So here, this is the same thing as like plus this, or drop the sign, right? This is this branch, and then the second one is this branch. We have to look for both values, right? Because the absolute value of 5 and minus 5 give me the same thing. It's 5. It's positive 5. So this is fine. This, if we add 5 to both sides, we get x is greater than 17. And if I do, if I put 100 in here, 100 minus 5, 95. The absolute value of 95 is 95, and that certainly is greater than 12. Hooray, we like that. Now this one, what do we do here? I'm going to actually distribute first. Right, so minus 1 times x is minus x, and minus 1 times minus 5 is positive 5. Ooh, and a terribly drawn positive 5. One more time, let's do it. Nicely drawn 5 is greater than 12, right? All I did was distribute the minus sign into the parentheses. Okay, now let's do some algebra. Subtract 5 from both sides. And I'm left with minus x is greater than 12 minus 5 is 7. This is the crucial part. I need to divide both sides by minus 1. I could do that. Divide by minus 1, divide by minus 1. These minus signs will cancel, giving me x. And 7 divided by minus 1 is minus 7. But recall what happens when we have anything other than an equal sign here. Inequality signs have a special rule that says when you multiply or divide by a negative number, the sign reverses. The sign changes direction. And this is the issue. And this issue only comes up when we put this minus sign in front of the argument, like the function definition tells us to do. Fine, so now I'm going to change this. It's going to go in this direction. And now I'm proposing that my solution is any x that's less than minus 7. Fair enough. Let's choose minus 30 is less than minus 7, right? So let's put minus 30 in here. Minus 30 minus 5 is minus 35. And the absolute value of minus 35 is 35, and it is greater than 12. So for this branch, I actually did get the right answer. And that's the issue. If you make this one change, by the way, with equations, we actually get away with it because nothing happens to the equal sign when I divide by a negative number or I multiply by a negative number. Nothing happens to the equal sign. The equal sign is the same in both directions. But here we have an issue. This has to happen when I apply this minus sign to the argument. When I apply the minus sign to the 12, there's no notion of dividing by a negative number. And that's where the problem comes in because it doesn't turn the sign around. If this was negative 12 and I just had x minus 5 as we did before, we have a fatal problem that gets us the wrong answer in this case. So the thing that I'm proposing that you do in order to handle these questions better is to simply go back to this and deal with placing the minus sign with the argument, as we did in this case. Let's just go back to an inequality. Okay, well, of course the battery had to die during this long discussion. But what I was saying was that what we should do is show, I'm just going to change this to an equal sign and show that the same exact procedure works. And then we'll be done for today. And magically we're back with an equal sign. Same exact expression. Now let's apply this technique that we talked about and show that we also get the correct answer. And that's why I suggest that we use this same technique regardless of what this is in here. Okay, here, x minus 5. So I want to find the positive one for the argument being positive. So all I do is drop the bars. Right? I just drop the bars. And then the next one is I'm going to apply the minus sign to what's inside the bars. Okay, fine. Right? And then here, same thing, plus 5, x equals 17. If I put 17 in here, 17 minus 5 is 12. The absolute value of 12 is 12. Great. Now let's use the same technique as we did for the inequalities here by using this branch of the function. Now we're using the definition of the function. I'm going to expand minus x plus 5 equals 12. This is what we had before. So I'm going to subtract 5 from both sides. Minus x equals 12 minus 5 is 7. Then I'm going to divide both sides by minus 1. X is minus 7. All right, let's put this in here. These are equals now because this is an equation. We have an equal sign. X equals minus 7. I put it in here. Minus 7 minus 5 is minus 12. The absolute value of minus 12, when we drop the sign, is 12. And sure enough, 12 equals 12. That's something that I feel like a lot of math teachers don't discuss. When I do these problems with my students, I just do problem set after problem set after problem set with people. And this is a sticking point that comes up an awful lot. But it's because of two things, the properties of the actual function and using the definition of the function when we set up our two equations or two inequalities, and then the peculiarities of what happens with greater than, less than, greater than or equal to, and less than or equal to. We kind of get away with it in the equation sense, Like I could not have done this. I could have applied this over here, right? Let's have a look at this one more time in a different way. Let's have a look at this without using the function definition, using the old way. So I would say x minus 5 equals minus 12. This is another terrible 5. I'll work on that. If I add 5 to both sides, I get x is minus 7. I sort of get away with it, right? I get away with putting the minus sign over here. With an equation, with an inequality, this absolutely fails, as we've seen. So I hope that this actually helps. And again, my one suggestion is to just use the function definition and apply this minus sign to the thing that's in between the absolute value bars, not the thing that's on the other side of the equal sign or the inequality sign. And without fail, you'll get the correct answer if you practice that, if you just reverse that like little sort of erroneous thing that you learned with dealing with equations. It's not extensible to inequalities. That basically is it. It's very simple, I hope. Thanks for joining me today. And let me know in the comments if you've learned something. And please ask any follow-up questions that you have. I'm happy to answer it in the comments, or if it requires a follow-up video or something like that, I'd be totally stoked to do that. All right, well, thanks again for joining me today. I really appreciate it. And just keep checking out my channel for new and interesting things where if your math teacher is terrible, I can help. Thanks again.